Nyní budeme mít BeeGFS, což je optimalizovaný paralelní souborový systém speciálně pro tu tolikrát proklamovanou AI, umělou inteligenci a high performance computing. Prezentaci nám představí Ingo Martini a bude nám tedy představovat unikátní souborový systém, který nalezne své uplatnění všude, kde je kladen důraz na vysoký výkon a velké objemy dat v řádech petabajtů. Řešení je postaveno na open source standardu s možností placené technické podpory, což si myslím, že je velmi zajímavé, a nasazení enterprise funkcí. Řešení BeeGFS se pravidelně umisťuje v top 500 instalovaných superpočítačů a každoročně je tento produkt označován za nejvhodnější a nejvýkonnější storage řešení pro high performance computing klastry. Jedná se už dneska o předposlední přednášku. Poslední bude potom od firmy Nodium. 15 hodin, tedy za hodinu, bude potom losování cen z vás účastníků, takže určitě ještě vydržte. A nejenom kvůli zajímavým tématům, ale i kvůli tomu, že se znova potkáme i s pány řediteli. Ingo, are you here? Can you hear me?
I can hear you perfectly. Can you hear me?
Okay, so I'm happy that you are here, and now 30 minutes is here for you.
Okay. Hello, and thanks to Agora to have this opportunity to talk a little bit about BeeGFS today. I have listened some of the presentations before. I know a lot of technical stuff today. I think we will do it a little bit lighter in things of technical details, more about use cases, how things working, how customers using our BeeGFS, and why they are interested in having something where the source code is openly publicly available. So please let me share my screen. I hope this works. Perfect. So let's move this around here. Okay. So I think you can see my screen right now, correct? Okay. Okay, so I believe if nobody is answering, everything is fine. So let's go forward about BeeGFS. So, okay, BeeGFS, a leading parallel cluster file system, mostly used in the HPC environments, and there are several, I would say, use cases where customer using BeeGFS. These are different industries. We have some on the scientific side for biological research. We have some on oil and gas. We have some in the automotive. We have a lot of customers also in media entertainment where they use BeeGFS for render farms because of the low latency that file system can provide. But in general, BeeGFS is a parallel file system that is mostly optimized for performance, scalability, and ease of use. And I think this is something worth to mention. BeeGFS is not this kind of enterprise storage that gives you 200 features with different licenses for each single feature and all this stuff. So we are trying to get or to have BeeGFS as small as possible so that it's really easy to use, easy to install. Of functionalities within the file system itself. It's really, if it comes to the point where you need something that is extreme high performance, then BeeGFS is the right thing to go. And for a lot of customers, it's very important to have a look into the source code of the file system. As we know, a lot of solutions out there have a closed source. They don't like that someone is looking under the hood and see what's going on here. That's different with BeeGFS. It is open source. It means the source code is publicly available, and there are two versions of BeeGFS. One is the community version, where you can say you can run the file system on your own installation. You can use all the features that are included in the file system itself. If you use it in a production environment, and if you use these so-called enterprise features, you should have a license for this. So the license, that means for us, it's a level 3 back-level support contract with ThinkPark. And then the customer can use it. If you are, I would say, a skilled Linux administrator, you should be able to install BeeGFS on your own hardware in your own environment within, for a demo installation within from 2 or maybe 3 hours. So that shows that it is extreme easy to use, especially if you think about, I would say, other parallel file systems where you have installation dates for several days, or where you need to set up a lot of things before. BeeGFS is running on a Linux-based storage server or on multiple of them, and they can be combined. If we go to the next slide. No, okay. This is the architecture of BeeGFS. That means we have different services that are running on the Linux server, and this can run on different servers or can run on one single server. So that means the smallest instance for a BeeGFS file system can be a single server with some storage attached to them. And there you can create your storage targets, metadata targets, monitoring, management, and all this stuff. And then this server can provide over the BeeGFS file system protocol, RDMA-based access to the clients that you are attached to them. That means it's really, to start with BeeGFS needs really, really less hardware on this. So if we go through all these stuff, we have first our management service. The management service is something that creates all the configuration and information that the client needs, what all belongs to BeeGFS file system. How many storage servers do we have? How can I reach to them? What's the IP address of these? Where can I find my metadata information for my file system? What's the IP address for this one? Where to send the monitoring information that the BeeGFS brings with them. And this is really a very lightweight service that's running here. It has nothing to do with the data transfer. It's only about the configuration, so that everybody that plays in this BeeGFS game knows who belongs to this group. The next one is the metadata server. Metadata server or metadata service means that is a service that runs metadata for a dedicated directory. If we can scale metadata services on a single server, but also over several servers, that means that we end up have multiple metadata services running. And each time a client creates a new directory, another metadata service will take care of this information, so that the metadata is really spread over several servers or services. And this gives us the possibility also to scale file systems, not only in the bandwidth performance case, but also if it comes to millions of file system operations at the same time. If you think about a big HPC cluster where you have maybe 200, maybe 600 clients or more, and they all want to do something with the file system, there is a lot of traffic on the metadata side. So you need to have the possibility to scale out also these metadata services. And that's what we're doing here. And then we use this algorithm to say, okay, each new directory get a new, will be sorted to a dedicated metadata server for this. The next one is the storage servers. This can be a server that has built-in storage, maybe some hard drives, maybe some NVMEs included, but also a server that is attached to a traditional SAN, for example, and has access over fiber channel or over NVMe over Fabric, or a SAS attached storage. So that means the storage server is a Linux box that has access to some LUNs, create their file system, and BeeGFS will collect all these LUNs together, all these file systems, create his own namespace on top of these local disks, and present this as one single namespace to the outside world. That gives the clients the possibility to talk to the meta servers, seeing one single file system, even if it depends on several storage servers that are stored below. The monitoring stuff is also a very lightweight service. This is running on one of these servers. Usually we do not have a dedicated monitoring requirement for this, so that we need a dedicated server. Also, that's something that we usually start on one of the storage servers or on the management host. And from there, we can collect all the information from the metadata server, from the storage servers, from management, from the clients, to create a very impressive user interface where administrators are able to see which clients produce how many files, which clients produce a lot of bandwidth requirements, which client is doing, has how many files accessed in the last few seconds. So, and this is not only to have nice pictures here, this is really important for a day-to-day work where an administrator has to find out, because a departure comes and says, yes, we have some performance issues. What this means? Do they not have enough bandwidth? Do they not have metadata performance? Is there a client consuming all the bandwidth that they usually should have? So in this way, it's important to have these kind of monitoring tools to really see what's happened here and what is the reason for the behavior of the system. The client, last but not least, is a kernel module that we compile directly on the Linux clients itself. So BeeGFS is based on Linux completely, also on the client side. That means on the client, we compile directly a kernel module, and then the client, when it starts, get the information, whereas the metadata and the management sorry, host to find. And during the mount, the client will get the information from the management host where to find all these other servers, and then they can mount the file system. And if a client wants to write or read something, they will communicate first with the metadata server, get this information, and then having direct RDMA-based access over the storage servers directly to the NVMEs or to the hard drives, depends on what kind of hardware you would use. It's important to mention that all other services that I talked before, management, metadata, storage, and monitoring, are running in user space. This sounds a little bit scary. Why is this important? It's important that you can do kernel updates on the storage server, metadata server, and the management host, for example, security updates, without having impact on the file system itself. Other file systems have struggling if you want to do a kernel update on the main components. If they have kernel modules for this, they will have some dependencies, and it can happen that it needs several weeks, maybe months, before the software vendor can provide the right patches for this. So this is not necessarily the case with BeeGFS, because the main components, storage, meta, management, they're running in user space, and you can easily update and do security updates on your systems without having the dependency that you need to look if your application, your file system is able to do this. Only the client service itself runs in kernel space. That's very important because we're using there some kernel internal algorithms and features for performance reasons, and that's why the client has a kernel module and will always have this created this during the first start of the BeeGFS client. Then we create automatically this module. That's important to understand. If the clients also get automatic updates and the kernel update happens, then the next time the client will start, then the client has to recompile the service and start the module from there. It's something that takes maybe 2, maybe 3 seconds. It's not a big thing, but you have to take care of this. That's all what I tried to explain today about the BeeGFS, how it works and what is the benefit of it. I think a little bit interesting here would be what real use cases we have with these customers. And one interesting use case I found in one of our customers here in Germany, or not based in Germany, is based in Denmark. It's a German-based company. They are doing a lot of research on automotive stuff and also on engine. And what they're doing, they're analyzing with their HPC cluster the flow and liquid flow within an engine combustion chamber. That means it's very complicated because you can't open an engine and look how it works. You have to analyze and you have to do some research there. If you change the size of the chamber, if you change some of the size of the valves, for example, or the angle how to inject the diesel into the engine, then everything has effect on the efficiency. So, and what they're doing for several years now, they have this kind of HPC environment where they do these simulations. And interesting enough here, this system was usually installed in 2016 initially and was created on Dell hardware. As I mentioned before, BeeGFS is completely hardware agnostic. We do not have any preferred hardware vendor. Is it on the server side, network side, on the storage side? And then this system was really running very long time. And then the customer upgraded in 2023. And there was one single reason for this, not to go to something else, because they have written a lot of software on their own. And it's also something similar I found in a lot of broadcaster environments. So a lot of media customers have their own scripts, have their own applications written for something. And here it was the same. And because BeeGFS is an openly available source product, you can have a look into it. This helps the customer really to optimize their applications in the way how they read and write data to the storage to get the best performance and also to get the best results out of their cluster. So with these optimizations, they were able to run not only 2 of these analyzes per week, now they run 6 of these analyzes per week, only because they can optimize their application in terms of how to talk to the storage on this. And this shows why customers are happy with this BeeGFS. They can take a look into it. They can do, if they have some research department or some software developers in time, they can have a look into this and see, okay, why does the system behaves like it is? I think this is not or nearly impossible with other solutions out there where you have a closed source. You can see what the performance is, and then you have to take it or leave it. And here you have the possibility to have a look into it, to fine tune it to your specific needs. And this is something that a lot of customers really do, especially if it comes to these optimizations, if it comes to high performance results. If you have multiple of these 200, 300, 400, 600 clients, then it's important to know exactly what's your application doing, what is the best behavior, and how can I fine tune this. And this is very easier for this kind of customers. Very interesting stuff. We worked with this customer for several years, and now last year we made this upgrade. And interesting enough, half of the hardware that they used in the initial installation, they will use also today. So even if it's already 6 or maybe 7 or 8 years old, they're still working with this hardware because it's work. They have 2 different pools with a high performance and I would say less performance but more capacity grade. And so they decide to run the old hardware for additional 1 or 2 years. And next year they plan to have new budget and replace this old hardware then. So that shows if you have this kind of combination, you are not, I would say, depend on the support duration from the vendors. You can say, okay, I like to use my hardware for another year or maybe 2. That's fine because it's independent, has nothing to do with a single vendor. Another use case that I like to mention here is something happens with my Zoom. Now here, okay. It's in the Middle East. That's an oil and gas company, and they processing seismic data. And they get this from satellites and also from some research companies that selling these data. And they have data sets of multiple terabyte each, and they do some analyze on this. The challenge here is really that they have to operate these single data sets in one. So what they have and the solution is right now 2.4 petabytes on storage, and they're operating here more than 60 NVIDIA DGX with 8 H100 GPUs inside. So if you come from the, I would say, HPC side of the world, you see these as the most expensive DGX boxes right now you can buy. Maybe next quarter you can buy an H200, but at the moment it's really an extreme powerful solution here. And they combine these NVIDIA DGX boxes with NetApp storage, in this case, with redundant meta and storage services, and they are connected over 400 gigabit InfiniBand, so that they can realize performance up to 350 gigabyte a second for read and 130 for write in performance. So this is very impressive how they use this. And for this customer, this is a growing project. That means really they looking for more of these boxes. They want to grow because it's very important for them to understand the value, where to find new oil resources, and also for other stuff. So because these companies are moving forward, they also interested in doing some solar energy things, also for changing or using solar energy to create oxygen and not oxygen, hydrogen. And this is where they have a lot of research there, and they're moving away from oil, more or less oil and gas. So they're trying to invent them the real new and get a new energy provider for the next 100 years or so. So that's why it's important for these customers to have this huge investment in research. And if you see these impressive numbers, at the moment they're thinking to double this in 25. I'm not sure if NVIDIA can deliver the hardware for this, but for us it's a really great project where we see also here the main factor for using this solution compared to I would say enterprise solution that comes with a appliance approach is really that they develop a lot of software on their own, and they are happy to have a look into the BeeGFS code. They can optimize their applications. They can, if they like, optimize the BeeGFS file system for their use case. So that's very important for them to have this approach and to see how to optimize this. File system metadata performance is for this customer not really, I would say, so dramatically important because they have very huge data sets. They do not have this trillions of files that we have on other HPC environments. That's not really here. But for them, that's not that's the benefit here is if they want to expand the system with more capacity, that's easily for them because they can add additional storage nodes from NetApp without having also the same time more meta information or more meta storage on this. As long as they do not need this and they do not need more metadata performance, they only expand the system on the storage side, on the capacity side. That brings them more bandwidth, but not more file system performance. File system performance, what I mean is file creations, deletes, removes, file stats, and all this information. That's the pure file system performance and not the bandwidth that the storage can provide here. Okay, these are two use cases from last year that we had projects with BeeGFS, and I think sometimes it's interesting to see how customers using these. And I have also a few use cases from the media entertainment background. Maybe one or the other knows that we are partnering with a company that used BeeGFS with their appliances to provide storage for media entertainment, for media production, for on-site recording. So there's a lot of others using BeeGFS under the hood. And important for us is always to get a good feedback from customers to know what they need, what is really the need, where is the issue with the pain point with their solution right now. And then we're looking together with our alliance partners, can be NetApp, can be Supermicro, can be Dell. Dell has its own appliances running with BeeGFS in the HPC environment. So all these big vendors have some relationship with BeeGFS to create these kind of reference architectures so that nobody has to start from scratch. You can go to Dell and say, okay, guys, I'm interested in a high performance HPC environment. Can you give something to me that is proven, where we have some benchmarking tests made and all this stuff? And Dell has this in their price book. They can easily offer this right now. What we have to develop together with NetApp and NVIDIA was the GPU direct storage stuff. So this is something that's very important for HPC right now, because then the GPU directly writes to the storage and reads from the storage and goes no longer over the CPU and the stack. So that also dramatically reduce the latency until the data is from the storage to the GPU and can be operated there. I think it's a big hype because the performance is really very impressive on this. The other side is that the software engineers have to rewrite their software. If they use standard POSIX commands to read and write data, that makes no usage of the GPU. So you need to use these CUDA commands for reading and write. But if you use them, then really you can speed up the load time from the storage up to 300%, because the latency is extreme low on this one. Another thing that is included in BeeGFS and makes life much easier for partners, for customers, and also for administrators on a daily work is that BeeGFS also supporting multi-rail networking on the client. If you have ever configured a Linux client with multiple RDMA-enabled network interfaces, you know this can be a challenge to get this sorted and really work on the best way it should. So this is now included with BeeGFS. That means the BeeGFS file system driver itself will select the right network interface, and there's a priority list. And then you can also select, okay, if I have a 200 gigabit InfiniBand connectivity, I will use them. If this connectivity is down, I can also switch to a 100 or 10 gig, even 10 gig Ethernet connection to finish my job, because in HPC we have sometimes jobs running with several days, maybe weeks for one storage or for one job there. And the most important thing here is really that this job is running and not canceled. And that's why they can live with a drop in performance, but not with a canceling of the job. So that's why this is important to have this multi-rail networking, so that if you have multiple network connections to the storage, BeeGFS will select the right one, the best one. And in case it fails, it will go down and also fail back if the connection is reestablished. So if you have a SFP or a cable issue, replace the cable and the system will immediately switch back to the highest performance possible. Another interesting thing for HPC environments is really that we support also ARM architectures. As we all know, there are some issues at the moment to get, I would say, hardware to a real pricing. So we know NVIDIA is the master and the champion on the market, but they're really struggling with delivering their products to the customers. So sometimes we're talking about 6, maybe 12 months on delivery time. And so more and more customers, especially in the Eastern Europe and in the Asia Pacific market, looking more and more for ARM architecture-based solutions. And BeeGFS is ready to go. So we have this implemented. We can use ARM architecture and also in the mixture. So if you have some x86 and some ARM clients, you can mix them on the same storage. The client can work on both environments, and you have one storage for both architecture environments. Okay, last but not least, because everybody shows a picture from his nice looking GUI and monitoring tool, here's one of our tools. I mentioned before, we can switch here to a very granular level up to the user, to a single user, and see how much files they create, what is the latency between the client and the storage, the latency between the client and the metadata server. So for our service team, this is very helpful in case some customer reports some performance issues. They can easily use this GUI and then show the customer, okay, you have a bottleneck in your network, or there's something wrong with your network connection or with the storage or whatever. So, and it's always easier to have here a look and see point to point where to find the issue than having a bunch of log files where you can parse and looking for timestamps to find an issue. And the benefit here is also, you see also the history. So if someone comes on Monday, oh, on Friday evening, we had an issue, the system was slow, then you can look here and say, okay, what happens on Friday? Was there a backup job? Was there something else? Was there data transfer, ingest from somewhere else that eat a lot of the performance? So this is something that you have, and it's easier to manage than a standard, I would say, log file parsing. Last but not least, who is ThinkPark? ThinkPark is the company behind BeeGFS. ThinkPark is established 10 years ago, so we have this year our 10 years anniversary. We are a German-based company, and we have owning the IP of the BeeGFS. So we are a small company, but we are spread all over the world. We have teams in India, US, Australia, in Germany, in Sweden. So really a very international company. And we providing development, support, consulting, and professional services for this. If customers like to do firmware updates, or if they like to do some consultant performance-wise, that's what we're offering. So usually we go with a partner channel model. So that means Agora is one of our partner, for example. They can do level 1, level 2, maybe also basic installations. But if it comes to a certain point where customers need, I would say, a higher level on consulting, then we can jump in. We have some specialists doing this. We're doing technical trainings for our partners and also for customers. And the most important thing that we try to bring, that ThinkPark is always looking that BeeGFS will stay hardware agnostic on all kinds of technology. That means if it's storage, if it's server, if it's networking, we're supporting all the protocols that you can imagine. If it's iSCSI, if it's SAS, is this Fiber Channel, is this Rookie, InfiniBand, OmniPass, name it. So we will support it. And yeah, I think that's it. Last but not least, but I think I will jump over this, why BeeGFS that's easiest to use, easy to manage, especially from the administrator perspective, from the customer perspective. It's not a huge monster. It's really easy to use. It's openly available. You can download the software every time. You have a full feature set. Only if you use these enterprise features, you should accept the EULA, and then you have the end user license agreement, and then you have to buy a license per server. We don't count in clients. We don't count in capacity or something like this. We only have the number of servers where BeeGFS services are running, and therefore you need a license, and that's it. So